Hello and welcome back to another video on discrete random variables and probability distribution functions. In this video, we're going to look at two worked examples together, but if you haven't tried these questions yet, pause the video, try to see if you can figure it out on your own. If you get stuck, go back and watch the first video to review what discrete random variables are and how we can generate probability tables from a given scenario. Okay, so here is the first question. A discrete random variable x has the probability distribution given by this formula, where x is equal to 0, 1, 2, 3, or 4. So we know this is a discrete distribution because x can only take on certain values. This is in contrast to continuous variables where x can take on a range of values. So discrete quantities are usually counted and continuous quantities are measured. Okay, so now based on this formula, let's see if we can work out what the probability table looks like. First, we're going to set up our variable lowercase x, and it can take on values from 0 to 4. When x is equal to 0, what I want to do is plug in 0 into my formula. So I'm going to get k times 1/3 to the power of 0 times 2/3 to the power of 4 minus 0, which is 4. And we're going to repeat this process for x is equal to 1, 2, 3, and 4. So for instance, trying to find the probability when x is equal to 1, we have k times 1/3 to the power of 1 times 2/3 to the power of 4 minus 1, which is going to be 3. Once we have all the values in our table, remember that the key result here is that the sum of all our probabilities must equal 1. So we can write an equation by taking all of these individual expressions, summing them together, and setting it equal to 1. From here, see how I can factor out a k. Now we're going to punch all these numbers into our calculator. And if you're wondering whether there's a shortcut for doing this or a more efficient way to do this, yes, there is. Come talk to me about it. So this value that we sum up ends up being 31 over 81. And now to solve for k, I multiply both sides by the reciprocal, which is 81 over 31. And so k is equal to 81 over 31. There's our answer. Part B, find p of x is equal to 2. So when we plug in 2 into our probability distribution function, we're going to get 81 over 31 times 1/3 to the power of 2 times 2/3 to the power of 4 minus 2, which is 2. Okay, and this turns out to be 4 over 31. Part C, find p of x is less than or equal to 2. So I'm going to do part C up here. When x is less than or equal to 2, well, that's the sum of the probabilities from x is equal to 0 to x is equal to 2. So I want to add all of those individual probabilities together. K is equal to 81 over 31. Since k is in all of these individual probabilities, I'll just factor that out. And we need to calculate what is 1/3 to the 0 times 2/3 to the 4th plus 1/3 to the power of 1 times 2/3 to the power of 3. And let's move this over, plus 1/3 to the power of 2 times 2/3 to the power of 1. Okay, So summing this all up, we will obtain a value of 28 over 31. And we are done for this question.